Now I am discussing a new chapter, Introduction to Three-Dimensional Geometry. Say, in a plane, generally whenever we discuss anything in plane, what we do? We take two coordinate axes, x-axis and y-axis. This is origin. You can imagine this line as x-axis, this line as y-axis. This is OX, this is OY, this corner is at origin. On opposite side, back side this wall, here this line is going on. This is negative direction of x-axis, we say x dash. And back side of this flooring from this point onwards, in the opposite direction of OY, a line is going towards infinity, back side of this flooring. So that can be seen here as this is negative direction of y-axis. We denote this by OY dash. So these coordinate axes we take whenever we discuss anything in plane. Now we are coming in space. Say this is x-axis, this line is y-axis. Now perpendicular to x and y, I am taking this line. Perpendicular to y and x, this line is z-axis. So here z-axis we denote by this way. This is z-axis. OZ. This line we consider as positive direction of z-axis, and on back side of this wall, line opposite to OZ, that will be OZ dash. So this side, this will be negative direction of z-axis. So here x-axis, y-axis and z-axis are coordinate axes. X-axis, y and z-axis are coordinate axes. Coordinate axis in the space. Everything now we are discussing in the space. In the space, x, y, z are coordinate axes. Now, say this line is x-axis, this line is y-axis. So this plane is XOY. XOY, it is a coordinate plane. This line is y-axis, this line is z-axis. This is YOZ. This line is x-axis, this line is z-axis. So this is XOZ. So this is XOZ plane. This wall is, you can imagine this as YOZ or YZ plane. Simply we can also say YZ plane. So this is XY plane, this is YZ plane, this is XZ plane. So here planes X, O, Y, Y, O, Z, X, O, Z. In short, planes XY, YZ and XZ or ZX. These are said to be coordinate planes. So you can see that xy plane, yz plane and xz plane, they are intersecting at the point which is said to be origin. That point is said to be origin, or we can say intersection point of coordinate axis is origin. So this point is origin, intersection point. Coordinate axis or coordinate planes is the origin. Here these coordinate planes xy, yz and xz, these are perpendicular to each other. These three planes are perpendicular to each other. These coordinate axes are perpendicular to each other. Now, because of these planes xy, yz and xz, xy, yz and xz, the space is divided in 8 parts. Say in a plane, when we draw two axes, x-axis and y-axis, in a plane we draw two axes, x and y-axis, plane is divided in 4 parts, which we say quadrants: first quadrant, second quadrant, third quadrant and fourth quadrant. But now in space, because of these 3 coordinate axes or these 3 coordinate planes, when these planes intersect, say this is up to infinity, xy plane, this is yz plane, also going back to this wall, yz plane, and this is xz plane, going up to infinity, back of this wall as well as back of this wall. So whole space is divided in 8 parts, and here we can imagine I am in only one part of those 8 parts. Space is divided in 8 parts, out of which I am belonging to only one part, front part, which is obtained by this x, y and z. So I am in upper front part. This line is x-axis, this line is y-axis, this line is z-axis. That means upper front part. I am belonging to upper front part. This room is belonging to in upper front part. So there are 8 parts. Each part is said to be octant. Now, coordinates of point. In the space, how to locate any point in a space, or if any point is given, then how to find its coordinates? Let me understand the procedure. Just discuss that this line x-axis, this line y-axis, this line z-axis. These lines we take a positive directions of x-axis, y-axis and z-axis, perpendicular to each other. Now, if we take any point on x-axis, every point on x-axis has y and z coordinate 0. If A is any point on x-axis, then its y coordinate 0, z coordinate 0. If B is any point on y-axis, then we take its y coordinate B, here x and z will be 0. If any point lies on z-axis, this is z-axis, then every point on z-axis, if this point C lies on z-axis, then its x coordinate, y coordinate and z, x and y will be 0, z coordinate will be non-zero. Let me say small c. So keep remember, any point on x-axis has y and z coordinate 0, any point on y-axis has y, x and z coordinate 0, any point on z-axis has x and y coordinate 0. So we are putting these statements, any point which has y and z coordinate 0, this lies on x-axis, this point lies on y-axis and this point lies on z-axis. So this is the property of a point which lies on coordinate axis. Now if any point is on xy plane, here I am taking a new diagram. Suppose here once again this line we are taking y axis, again I am taking coordinate axis, x axis, this is y axis, this is z axis. This is space. In space we have taken coordinate axis. Now suppose if any point, it is, this point is on xy plane. If any point is on xy plane, then its P has x coordinate A and P has y coordinate B. Taking perpendicular from P on axis, a port lies on this number, and here taking perpendicular on y axis, if a port lies at this number, then this point has x coordinate A, y coordinate B and it has z coordinate 0. So any point which lies on xy plane has z coordinate 0. Similarly, if any point, say this is the point which we have discussed, point of this wall. A point lies on this wall, this line here we discussed in the beginning that this is x-axis, this is y-axis. So plane containing backbone is xy plane. Similarly, in the beginning we discussed y-axis, then this line was z-axis. So this wall is yz plane. So if any point lies on yz plane, then its x coordinate is 0. Similarly, so in this diagram we can say this plane is yz plane. Here I am removing this part of diagram to show whatever I want to say clearly. This is yz plane. If here point Q lies on yz plane, then taking perpendicular, here this is the port lies at this number, and here taking perpendicular, here this is the port. So if this number is suppose 5, this number is suppose 4, then this point has y coordinate 4, z coordinate 5, but x coordinate 0. Any point on yz plane has x coordinate 0. So coordinates of Q are 0, 4, 5. Any point which lies on yz plane has x coordinate 0. Similarly, any point which lies on xz plane, any point which lies on xz plane has y coordinate 0. So we can put these statements individually as discussed. For this point, here 3 more statements. Any point on xy plane, has z coordinate equal to 0. Similarly, any point which lies on yz plane has x coordinate 0. Any point which lies on xz plane has y coordinate 0. So to understand these statements, here see I am putting few examples. Point 4 0 0, this point lies on x-axis. If I take x coordinate 0, y coordinate minus 2, z coordinate 0, if x and z both coordinates are 0, then this point lies on y-axis. If any point has x and y coordinate 0, x 0, y 0, z is non-zero, then this is on z-axis. If any point of this form, suppose 3 minus 4 0, so it is of this form whose z coordinate 0. If any point has z coordinate 0, then it lies on xy plane. This point lies on xy plane. If any point has x coordinate 0, suppose x coordinate 0, y coordinate 4, z coordinate 3/4, only x coordinate 0, that means this point lies on yz plane. Yz plane, this is yz plane. If any point has y coordinate 0, y coordinate 0, suppose x coordinate is 3, y is 0, z is 1, only y coordinate 0, then it lies, this point lies on xz plane. So if any point lies on coordinate plane or coordinate axis, then these are the properties of such points. So this was about points lying on coordinate plane or coordinate axis. Now see, when we take axis, x-axis, this line is y-axis, this line is z-axis, this is O, this side, this is negative direction of x-axis, we say x dash, this is negative direction of y-axis, we say y dash, this is negative direction of z-axis, z dash, this is origin. Now see, taking these 3 perpendicular lines, the whole space is divided into 8 parts. Each part is said to be octant. Let me define octant by these symbols. Say here octants, and here coordinates of a point lying in octant. That means, say here I am preparing a table. This is divided in 8 parts. Each part is said to be octant. First octant, then second octant, third octant, fourth octant, fifth octant, sixth octant, seventh, eighth octant. Then here, if any point lies in this octant, what about x coordinate, y coordinate and z coordinate? See how to prepare number and name of octant, that I am explaining. There are 8 octants. Space is divided in 8 parts. Say, to understand these 8 parts, once again I explain. Imagine this picture, that this room is a space. Now in this room, you consider 3 perpendicular lines. Suppose there is a wire from midpoint of this wall to midpoint of this wall. A wire is considered, this line you consider as x-axis. Then second line, from ceiling to this flooring, consider second wire or bound second wire intersecting first one. So this wire is x-axis, this wire is y-axis. We are doing this in this room. Consider third wire, which is bounded from this point, center of this wall, to the center of opposite wall, in such a way that this third wire is intersecting first and second wire. So here first wire x-axis, second wire y-axis, third wire z-axis. These wires are intersecting in this point, which is origin. Now use curtains. Put curtain. Say here this was x-axis, this was y-axis. So consider xy plane. So this is xy plane. So put curtain along xy plane. This is first curtain. This is y-axis, this was z-axis. So second curtain. Imagine YZ axis as second curtain, YZ axis. This was XY axis, XY plane. This curtain is YZ plane. Now third plane, this wire x axis, this wire z axis. So XZ plane, this will be XZ plane. So consider XZ plane is a third curtain. So overlap this plane by curtains. This is XZ plane, this is YZ plane, this is XY plane. So see what is happening. We have constructed 4 rooms, 4 partitions in this room. Because of this construction, curtains first, second and third, there will be 4 rooms in upper part and 4 rooms in lower part of this room. So room is divided in 8 parts. Each part is octant. Room we are considering as a space. So here, now front 4 rooms. See, front side 4 rooms. This line will be common. Z, positive Z axis will be common in front 4 rooms. See, 2 upper rooms and 2 lower rooms. So front 4 rooms. Now I am giving name of front 4 rooms. You can remember by this way. This is x, this is y, x dash, y dash. See, first quadrant x o y, this is first quadrant x o y, x dash o y, x dash o y. This is second quadrant. Third quadrant is x dash o y dash, x dash o y dash. Fourth quadrant is x o y dash. So you can remember these four quadrants by these symbols. Dash means negative, x dash, that is negative. Here x and y coordinate negative, here y coordinate negative. Fourth quadrant. Now I am repeating this once again. See, repetition of x o y, x dash o y, x dash o y dash, x o y dash. Now what I do? Here imagine z axis, this side, z axis. So I apply z. So put here z, 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 z. So what is obtained? Putting z, see, upper right side part, that is first octant. Then we have taken second octant, then third octant, then fourth octant. First octant, second octant, third octant, fourth octant. Now go back side. So back side 4 rooms in the same sequence. So back side 4 rooms, first, fifth, sixth, seventh, eighth. So for back side we join z dash. For front side we join z. So here z is joined. For back side join z dash, z dash, z dash, z dash, z dash. So these are 8 octants. If any point is in first octant, x coordinate positive, y coordinate positive, z coordinate positive. If any point is in second octant, x coordinate negative, y positive, z positive. Here x negative, y positive, z negative, y negative, z positive. X negative, y negative, z positive. Dash is over y. Here x positive, y negative, z positive. X positive, y positive, z negative. X negative, y positive, z negative. X negative, y negative, z negative. X positive, y negative, z negative. So this is the way to find location of any point, whether it lies in which octant. As for example, say here point, suppose I put 2 minus 3 4, x positive, y negative, z positive. So it lies in, say x positive, so put x, o, y negative, so put y dash, z, z positive. So it lies in this octant. What is number of this octant? So say here this defines x positive, y negative. This defines fourth quadrant. X positive, y negative defines fourth quadrant. That means fourth partition, front side, so fourth octant. So it is fourth octant. This is fourth octant. Fourth octant. X, O, y dash, z. Then if I put here P 2 minus 3 minus 4, then this lies in, say x positive, then put O, y negative, put dash, z negative, put dash. Now this part defines a fourth quadrant. To remember octant, take help of quadrant. Quadrant related to plane. So x positive, y negative. That means fourth quadrant. Now z dash. So take back side. So back side, that is eighth quadrant, eighth octant. It lies in eighth octant. If any point P, suppose -2, 5, 6, this lies in, x is negative, so put dash, y, z positive, so don't put z or y and z. So x negative, y positive, second octant, this is second octant, x dash o, y dash, it lies in second octant. So we can locate points in space by this method. And to find coordinates of any point, whenever any point we are given, then if coordinates are ABC, then what we do? Take from that point, take perpendicular line on x-axis in the space. So here you will find A. On y-axis, take perpendicular line. So here you will find B. And take perpendicular line on z-axis. So here you will find C. So perpendiculars are taken from that point on coordinate axis. So here A, B, y coordinate B, z coordinate C. So this is useful to find location of point in the space. Now distance formula. Distance formula in the space. If any 2 points A and B are given, whose coordinates are x1, y1, z1 and x2, y2, z2, then distance between them AB is square root of x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. As for example, if A is 2 minus 3, 4 and B is 4 minus 1, 0, then distance AB is square root of, by this formula, x1 minus x2 square plus y1 minus y2 square, y1 minus y2 square plus z1 minus z2 square. So this is equal to square root of 2 minus 4, minus 2 square is 4, again minus 2 square is 4, 4 square is 16. So it is square root of 24. 24 is 4 into 6. So this is 2 root 6. So distance between these points is 2 root 6. Now in this question, verify these are vertices of a right angle triangle. So to prove or to verify this, let me label the name of points. Let me say E is 0, 7, 10, B is minus 1, 6, 6 and C is minus 4, 9, 6. A, B, C. Now to check whether they are vertices of right angle triangle or not, we use Pythagoras theorem, for which we find distances. Here AB is square root of x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square, that is square root of 1 square is 1, again 1 square is 1, 4 square is 16, so it is root 18. AB is root 18. Then BC, applying distance formula in B and C, x1 minus x2 square, x1 minus x2 square plus y1 minus y2 square, z1 minus z2 square, square root of 3 square is 9, here minus 3 square is 9, this is 0, so this is root 18. BC. Now we find AC. AC is square root of x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square, that is square root of, this is 16 plus 4 plus 4 square 16, so it is root 36. So AB is root 18, BC is root 18, AC is root 36. So see, AB is root 18, so here AB square is 18, here BC square is 18, and here AC square is 36, and you can see that sum of these two numbers is 36. So it is clear that AB square plus BC square, AB square plus BC square is 18 plus 18, 36, and it is equal to AC square. So therefore angle ABC is 90 degree, or AC is hypotenuse. So given are vertices of right angle triangle, therefore given are vertices of a right angle triangle, find the equation of set of points which are equidistant from this given 2 points. We take this point as A and this point is B. Say A and B are given. These are fixed given points. Now we want equation of set of points. That means suppose this is required point which is at equidistant from A and B. So P is the point such that AP equal to PB. Here P can be at this location also. So AP equal to PB. P can be at this location also. AP equal to PB. P can be here also. AP equal to PB. There exist such many points. There are many points P satisfying condition that AP equal to PB. So we want equation of these points, means an equation which is satisfied by these all points which are equidistant from A and B. So suppose that P is the point such that distance of P from A equal to distance of P from B. PA is equal to PB. PA is PB. So PA square equal to PB square. Now applying distance formula, because here we are calculating for square, we don't put radical sign. Radical sign is removed. So x minus 1 whole square plus y minus 2 whole square plus z minus 3 whole square equal to PB square x minus 3 whole square plus y minus 2 whole square plus z plus 1 whole square. So therefore x square minus 2x plus 1 plus y square minus, this is 2, minus 4y plus 4, this is z, so z square minus 6z plus 9. On other side, x square minus 6x plus 9. Here y square minus 4z plus 4, this is 2. Then here z square plus 2z plus 1. Simplifying this, say this x square is cancelled, y square is cancelled, z square is cancelled. So this means minus 6x take on this side. So 6x minus 2x is 4x. Then here this was minus 4y, sorry, minus 4y take on this side. So this minus 4y is cancelled. Then minus 6z, this is 2z, 2z take on this side. So minus 8z. 1 plus 9 plus 4, this is 14. Here 9 plus 4, 13 plus 1, 14. 14 is cancelled. So this is equal to 0. So that is x minus 2z equal to 0. So which is required equation? Which is required equation. So all the points in the space which are equidistant from these 2 points will satisfy this equation. This is equation of a plane. Here between these 2 points there exists a plane. Between A and B there exists a plane. So if you select any point on this plane, then it will be equidistant from A and B. So that is meaning of this question. Find the equation of set of points P, the sum of whose distance from A and B is equal to 10. Say here E is given 400, B is given minus 400, and P is the point such that sum of whose distance from A and B, that means PA plus PB, it is 10. So let P be the point such that its distance from A, its distance from B, and sum of these distances is equal to 10. So now we want equation of point P. That means equation which will be satisfied by coordinates of every such point P. So here PA means distance formula. Using distance formula, PA is square root of x minus 4 whole square plus y minus 0 whole square is y square plus z minus 0 whole square is z square. plus PB, so square root of x minus minus 4, that is x plus 4 whole square, plus y minus 0 whole square is y square, z minus 0 whole square is z square, equal to 10. This implies square root of, say here first term is x square, middle term is minus 8x, minus 8x I am putting inside, x square minus 8x, plus 16 I am putting here, y square z square keep as it is. What I have done, I have arranged x square minus 8x plus 16 plus y square plus z square. Similarly here, square root of x square put, then put y square, then put z square, then put here last term 16 and then put middle term at last, equal to 0. So in this expression, now this part is common. So we are taking, for convenience in calculation, we are taking x square plus y square plus z square plus 16 equal to m. This part we are taking m. So equation is square root of m minus 8x plus square root of m plus 8x equal to, sorry, this is 10. This is 10. Now, to remove this radical sign, we are taking square, squaring on both sides, squaring on both sides, this will be 100. Taking square to remove this radical sign. So therefore, now m minus 8x root m, it is like a plus b whole square, so a square is m minus 8x, middle term is 2 times square root of a into b, that is m square minus 64x square, this is middle term, plus last term will be m plus 8x equal to 100. Therefore, now this plus 8x minus 8x will be cancelled. M plus m is 2m. M plus m, 2m. This 100 I am taking on this side, so minus 100. And this number I am taking on that side. That is, keep this number 2 times root m square minus 64x square. Keep on the left side, and m plus m, 2m I am taking on this side, so this will be 100 minus 2m. Now dividing by 2, square root of m square minus 64x square is 50 minus m. In the beginning we had radical sign in 2 numbers. Taking square, now it is in single number. Now to remove this radical sign, once again we are squaring. So squaring both sides, m square minus 64x square, it is equal to 50 minus m whole square. Therefore, m square minus 64x square equal to, squaring this 2500 minus 100m plus m square. Again this m square is cancelled. Minus 64x square equal to 2500 minus 100 into m. Now what is m? This is m. Putting value of m here, x square plus y square plus z square plus 16. So this is minus 64x square equal to 2500 minus 100x square minus 100y square minus 100z square minus 1600. That is, now 100x square minus 64x square, that is 36x square, plus 100 y square plus 100 z square equal to 2500 minus 1600, that is 900, divisible by 4. So 9x square, 25y square, 25z square equal to, this will be 2 into 4 8, 2 into 4 8, then again 2 into 4 8, 5 into 4 20, 225 into 4 900. So this is required equation. Find the coordinates of a point on y-axis which are at a distance of 5 root 2 from the point P 3 minus 2 5. Say required point is on y-axis. So that point will have x and z coordinate 0. So starting of the solution is that let the required point on y-axis be, let me say it is A, and because it is on y-axis, its x coordinate 0 and z coordinate 0. We suppose y coordinate is, we can use any symbol. Suppose we are taking B, or we can take A0, A0, whose distance from point P is 5 root 2. So distance of A from P is 5 root 2. Therefore AP square, it is equal to 50, squaring on both sides. Now here using distance formula, AP square is, see, x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square equal to 50. Because of square, we do not put here radical sign. Radical sign is removed because square is taken. So therefore, this is 9 plus a plus 2 whole square is a square plus 4a plus 4. This is 25 equal to 50. So a square plus 4a, 9 plus 4 13, 13 plus 25 38, 38 minus 50 is minus 12 equal to 0. So that is a plus 6, a minus 2 is 0. So a is minus 6 or a is 2. So required point is, therefore required point is, putting here a minus 6, 0 minus 6 0, or second possibility is 0 2 0. So these are the points on y-axis which are at a distance 5 root 2 from given point.